INP, ठीक है. It's written that it's a core web vital, but there are so many core web vitals. Why did I choose INP specifically? So the reason is, first of all, it's the talk of the town. Why? Because it's the newest kid that has been introduced by the Google team as one of the core web vitals. Earlier, we had three core web vitals. We had LCP, we had any guesses about the other two web vitals? We had LCP, we had FID, and the third one, does anyone know here? Anyone? Okay, no worries. We'll see what are the three web vitals that we are going to talk about. Before that, let me just introduce myself. So hi, I am Suman Ghosh. I'm working as a front-end engineer at Cred. And at Cred, I'm working with internal tools which handles rewards, referrals, and other items as well, payments. Then previously I worked at Navi. So at Navi, I was a full stack developer wherein I was working in a lot of apps that you might be seeing in Navi. So you might have, if people might have used the Navi Mutual Funds app or the Digital Gold app, then you might have already seen my work. So thanks a lot for joining in. Again, cool. Before even starting about INP, let's understand that what are core web vitals and why they are important. So core web vitals are nothing, but it's just a metrics to understand how fast your web would be, right? How fast, how slow, just the metrics of it, and how the user experience would look for it. Now, currently, the core web vitals that we are having, they mostly consider three aspects of it. Consider three aspects of the user experience. Obviously, it cannot consider a bunch or like user experience has a lot of components, right? So currently, it just considers three aspects, which is loading, interactivity, and visual stability. The one that we are going to talk about would be the interactivity part. Yes. So as I told you, let's first see that what were the web vitals, the core web vitals, and we'll just jump into what the web vitals are now. So initially we had three web vitals here, LCP, which considers the loading, which measures the loading of your website. We had FID, which considers or measures the interactivity, as in you click on a button, right? If you click on a button, how soon you are getting the frame on your screen, or how soon you are able to see the particular elements on your screen. That was calculated. That was measured, that particular interactivity. The first input delay, that was measured by FID. The last thing, the third one, is CLS, that calculates or measures the visual stability, that sees as in if there are any layout shifts on your website or not. So yeah, these were the core web vitals. And as I told you, let's see how the metrics goes on. So how a good website, when we are saying ki, acha, this is a good website and it looks good with respect to the core web vitals, how they actually work upon. So for LCP, the count, the metrics, if the LCP must be within 2.5 seconds. If it has that measurement, then it's considered as a good website. For FID, it is 200 milliseconds because obviously, if you are wanting, if you're doing an interaction on your website, you would want that should be in milliseconds, right? That shouldn't even take a second. So yeah, it's in milliseconds. Then you have your layout shift. It's not calculated in terms of milliseconds or seconds. It's calculated in terms of the decimal values that you've seen. So if it is less than 0.1, less than or equal to 0.1, then it's considered a good CLS metric. Cool. Now coming that what are the core web vitals, and one of the web vitals that we are going to talk about. So this is the one. FID has been replaced by INP. We'll understand that what is INP and why was it replaced in first place, and what is the difference between INP and FID, right? Obviously, Google has come up with a new core web vital. Okay, one more important thing that I would like to tell here. So INP was already present. It's not something that is very new for people. It's just that it wasn't in a stable state. So generally, when a core web vital comes in, there are three steps. It's generally in an experimental phase. Then you have a pending phase, and then you have the stable phase. Once Google comes with the stable phase, only then it launches it. So earlier, and when it was launched, it is quite new, guys. It's just been launched on 12th March 2024. So it's just been 1.5 months for INP being considered as a core web vital. So yeah, that is why we are talking about it. And yes, for INP again, the similar stats we would require if a page has an INP calculation of less than or more than 200, less than and equal to 200 milliseconds, then it is considered a good number for a website. Cool. Why core web vitals? Why do they matter? That's a very important question, that why are we considering these core web vitals in first place? Obviously, if you might have seen your own experience, if you are working, if you are interacting with a website, the least thing what you would want, that should interact very fast, right? That's the basic thing that you want. After the UI, obviously the UI looks good, but if the buttons and the interactions that you might be doing, they're not working, the UI doesn't work, right? So yeah, so that's a considerate thing when we consider, okay, our website is good, it's performant, I like it. So yeah, these are the metrics. Now, why core web vitals they matter? Obviously the user experience, right? You guys are yourselves using a lot of websites day to day. You like it because they are fast, right? You want at a certain milliseconds, whatever interactions that I'm doing, I should get a result of it, right? So user experience first of all. Next thing, SEO benefits are always there. And the third thing, business impact. So why I'm talking about business impact? Every product, everyone might be working on quite a lot of products here. So everyone knows whatever we do is just for a business metric, ultimately, right? It's not just from the tech point of view, but it affects the business. That is why we are doing those certain amount of changes. So I'll just present some stats in front of you, as in if a website is not faster, what can be the considerate amount of drop off from a particular website or a web app. So you can see 53% of the online shoppers expect that within 3 seconds, the e-commerce page loads. Or else they are dissatisfied, they'll just drop off from that particular website. 21% of the customers say if slow loading pages are the main source of dissatisfaction, due to which they drop off from a website. Half of the customers will abandon their shopping carts if, again, it's not fast, right? And the last thing, if pages are slow, then you can see at least 45% of drop off from the website of the customer. So obviously, no business would want that, right? That is why the core web vitals come into place. Now, what is INP? Considering our main topic that we were talking about, INP. Remember, when I was showing these three pictures, I told you three things. In Core Web Vitals, we consider three aspects of the performance. First was loading, second was interactivity, and third was your visual stability, correct? And here we are going to focus on the interactivity part. So what does INP consider of? So it is just the metrics which assesses the page responsiveness. By page responsiveness, again, it is nothing but the interactivity itself, right? So in this case, responsive, don't consider it to be a media query sort of a thing. The responsiveness means that when you are interacting with a page, how soon you are getting the response. And how it does it? It uses the data from the event timing API. Now, when I say interactions that you are doing, right? Interactions. Now, what sort of interactions are these? And you will see the word that I'm talking about here, no, so many times. Interactions, this term is very important when we are seeing INP, because everything that is happening in INP is just the interactions. So it is important to understand that what are interactions, what interactions INP is considering to calculate its metrics, right? So in case of INP, they observe the latency of all the click, the taps that you are doing on the screen, and the keyboard interactions. Remember these three things, which are very important when we are going to move forward in the next slides. So it's very important, like INP consider these interactions when they are actually calculating your metrics for the responsiveness. And what it does, it calculates the longest interaction that happened after the load of your page. When you're doing an interaction, the longest interaction that happened throughout the page, that it considers as an INP metric. So what was FID? I'll again talk about it, that what was the difference. But before that, let's understand that what a good INP score is. So a good INP score, a good INP score is less than or equal to 200 milliseconds. You would need improvement if the INP score turns out to be 200, like more than 200 to 500 milliseconds. And if it is more than 500 milliseconds, sorry, boss, you'll have to work a lot on the speed. Cool. Now understanding that what is the difference between INP and FID since it replaced it, right? So consider both of them are ultimately interactivity metrics only, right? Now, INP is just a better version of FID. It's a successor of FID. How? I told you, both of them are responsiveness metrics. Just that FID, by the name you can see, first input delay. It just calculates, it just measures the input delay for the first interaction. Whatever first interaction you did on the website, it calculates according to that what is the FID score that comes out for your website. But in case of INP, it's not just that one interaction on the first or the last interaction that you are doing. It's an amalgamation of all the input delays and all the complete input delays that goes on throughout your website, and it considers the longest input delay basically. So I'll just read this out. INP improves the FID by considering all page interactions. As I told you, that is the main difference. It considers the first interaction. It is going to consider all the interactions that you are having in your page. And secondly, it is going to finally, it begins from the input delay. We'll talk about what is input delay, and to the time it takes to run the event handlers, and finally up until the browser actually paints. So as I told you, it considers all the interactions till you have actually done your, you have clicked on a button, right? Till the point the website or the interaction that you actually want to load on your website. Till that point when your interaction shows up on the screen, the complete interaction, the complete page interaction, the longest page interaction is taken into consideration by INP. So that's the difference, and that is why FID was initially replaced by INP. Now, interactions, as I told you, is a very important term when we are considering INP. So what is an interaction? If you see this image, can you see these three important terms? Just look at these three terms: input delay, processing time, and presentation delay. In case of your INP, the interactions that they consider would be, I told you again, it is click number one, tap on a screen. Third thing, keyboard interactions. Okay, these are the three interactions that they are considering. Now, these interactions itself are broken into three segments. What are these segments? This is the input delay, the processing time, and the presentation delay. Let's understand that what are these three components, because when we are going to discuss about the optimizations, right? These are the 3 points which would actually help you in understanding. These are the problems. These are basically the problems that are hindering you from getting a better INP. So once you understand these, you'll be able to understand how to reduce these delays, right? Ultimately, the website is taking some time during that interaction also, right? So we need to reduce the interaction ultimately to get a better INP metrics. So yeah, these are the 3 segments. The first one is your input delay. What is your input delay? It is basically, so let's say you have a button, right? You have added a click interaction over that, right? On that click interaction, what you do, you just add a callback, right? You add a function that once this happens, once a person clicks on this button, I'll call this function, right? That is what happens. So the time from where you actually clicked on that button, you made the interaction, till the time the callback is being called, this is the time which is considered as your input delay. So the time when the user initiates an interaction until the event loop starts running, that time is called your input delay. The second is your processing time. Now your event callback has been called, right? It has started running. So the complete time till the point the interaction has actually loaded on your web page on the browser, that time is called as your processing time. The third portion is your presentation delay. Now, after that, obviously, you have added the interaction, you have clicked it, you have added the callbacks inside it. Now the callback has run, it has given you the output, but it needs to render on the screen also, right? There can be an issue in the rendering as well. So that time, the time required for the browser to actually load the result that you got from your callback, to actually render and display it on the screen, that particular time or that delay is called the presentation delay. So these are the three segments in which your interaction is actually divided into. Now, as I again told you, I'm talking a lot about these interactions. These are the ones that I already told you, clicking, tapping, and obviously the keyboard interactions. But what are not considered as INP interactions, that is also very important to understand because there are so many interactions, right? So hovering is not an interaction. It won't be called an interaction because a person would obviously hover on screens, right? He would scroll over the screen. So no, that is not considered as interaction in INP. But the exception is that if you are scrolling using your keyboard, because remember I told you that using the keyboard interactions, that is considered as an interaction for INP. So if you're using a keyboard to slide like scroll up and scroll down, page up, page down, in that case it surely considers as an interaction for your INP, but not hovering and scrolling. Now, okay, we understand that what is INP, what are the interactions that are there in it, but yes, how to understand ki yaar, this is the website from where I'll actually see ki this is the problem. I know what are the problems. There could be some problem with the input delay. There could be some problem with the processing time. There could be some problem with the next set of tasks that we have in an interaction. But how to find that? So you have Lighthouse, you have Google Pay Speed Insights, you have RUM providers. So generally, RUM providers are of two types. You can use third-party RUM providers also, and generally companies have their own services which are RUMs. So those providers you can use because they are the data of your user base. CRUS, it is field data generally provided by Google. So if you want to analyze on that, you can surely analyze. So these are the ways in which you can actually diagnose your INP issues. They provide Google's and especially Chrome. It provides you a very good UI where you can actually inspect things and see that where is the problem actually coming and in which all metrics, what are the values that might be causing this problem. So yeah, that is the way you can actually diagnose INP. Now the question comes upon the optimization. We know, okay, what is INP? We know what are the problems. You remember the problems, right? The three problems and where there is a scope of bringing in solution or optimizing things. So here comes understanding that how we can actually optimize INP. Okay. Can any one of you or if you guys can recall with me, what are the three segments of an interaction? What did we have? What was the first segment of an interaction? Anyone? Input delay, absolutely. Second was correct, processing time. And third one was presentation delay, absolutely right. So now let's understand how using all these segments, we can optimize these segments for sure, right? We can reduce the input delay, we can reduce the processing time, we can reduce the third one, your presentation delay also. How to do that, we'll understand in the optimization part. So first thing we'll understand when we are talking about the input delay, everyone knows what is an input delay, right? How to reduce it, we are going to learn on how to optimize interactions. The second part, we'll understand how we can optimize event callback. So it is basically the processing time, how your JavaScript gets loaded and how the input, like how you get the output. We can obviously optimize on that part. And finally, when things render on the screen, the presentation time, that can also be fixed, that we are going to learn in the last 2 points, how to avoid layout thrashing. And the last one, minimize presentation delay. So let's see each of them. Okay, minimizing input delays. What is the input delay? Remember I talked about, in case of input delay, when you click a button, you are calling a callback, right? You're calling a function and you're expecting the function to return something. So the first issue sometimes that happens is because of the recurring timers, and the two timers that we generally use in JavaScript are set time out and set interval, correct? That are the two things we use the most. So we should avoid both of these. if we are wanting input delay to minimize, that is one solution. But don't consider it to be like, shouldn't I even use set timeout at all, or shouldn't I use set interval at all? See, the problem is that what set timeout does, it's going to execute your function after a given time, correct? Now, let's say it takes 3 milliseconds. Okay, it takes 3 milliseconds to actually process the complete function and show you the result. But let's say after the timer has quitted and you have the output, the question is the user going to wait till that point to actually see the interaction? If yes, then though obviously you should go for set timeout and set interval, because it also helps you to defer the long task that you have. So that is one thing. So consider when I'm saying that please avoid using set timeout and set interval. It's not just कि यार fully यार कहीं पे we shouldn't use it as such. No, you should understand that where you need to use it and where you not. In case of this case that you have, in case of input delays, you should avoid using it where you don't need it at first place. So yeah, that is the one thing. Second thing, I talked about long tasks. What are long tasks? Generally, the tasks that take more than 50 milliseconds are considered to be long tasks. So you can minimize those long tasks. And how you can do that? You can break them into small ones, and you can avoid like blocking the main thread. Ultimately, we just don't want to block our main thread, right? That's the main funda that we have in JavaScript, or anything that we are doing in JavaScript, right? Don't block the main thread. Don't do anything that would congest the main thread, right? So that's the idea here, that whatever long task that you are having, minimize it, because more the time that it's going to take, the task is going to take, obviously it's going to hamper your input delay, right? It would increase your input delay. Again, it would increase the processing time also, and ultimately your INP would be affected. So that's the second way you can actually minimize the long task. The third way, when I talked about not congesting your main thread, one thing that should come in your mind as a solution is using a web worker. But again, depends on your use case. Should you actually use web workers in that case or not? Right? So one solution can be to not block your main thread, would be using a web worker. Yeah. So next, there is one more thing. Let's say, consider what happens sometimes if you clicked on a button, right? Sometimes it doesn't give you the result that you want quite fast. So what you do, you click on the button again and again, again and again, right? Now, what is happening in that case? The interaction that you're wanting in the backend, the callback is being called again and again, right? How to fix it? That is again a problem, because let's say you clicked on second time, the callback is being called again, the function is being called again, but the first function hasn't completed yet, right? And you have started calling the second function. So that can again increase the input delay. How to reduce it? You can debounce, obviously. That's a first solution. And generally, like a lot of companies have been using the solution to reduce the input delays, debouncing. And I think many of you are already using debouncing in your codes, in your code bases, and doing a lot of items. So debouncing is a solution of overlapping the interactions. We should minimize overlapping interactions. So that's the first case. The second thing that you can do, so let's say an API is being called, obviously, right? So let's say you are calling the button again and again, due to which the API is being called. So in that case, for the ones, for the API calls that you don't require now, the current one, and just leaving apart the earlier ones, you can use a abort controller, which would cancel your ongoing request that you have. So that's how you can minimize your input delays. Next is your script evaluation and its impact. This is the second one. So first one, we talked about how to reduce input delay. A part of it was minimizing the interactions. If we minimize the number of interactions, then we are able to like reduce our input delays. Second part of it is script evaluation. So generally, when our JavaScript runs and executes, it compiles, there is one step that comes into the picture. And if you'll go to your Lighthouse and check how the things are running, you'll see one of the part is evaluate script when the code gets compiled. And this is one of the main problems that is hampering your input delay and the processing time of your particular code and interaction. So let's see how we can actually reduce it. So what's the problem? Let's understand the problem. The problem is with the time again, right? the time that it's a particular interaction is taking to process. How to reduce it? So there are a few ways. Many of you might have used dynamic imports. Have you guys used dynamic imports, right? People might be knowing about it. So similar kind of a steps we can take so that we can reduce the processing time. So this is the second aspect of the interaction that we are talking about, how to optimize the processing time. First thing, you can use smaller scripts. The larger scripts that you're using, you can break it into chunks and you can provide it in smaller script tags, script elements. Next thing you have type equals to module attribute. Generally, the script tag that you add, it is considered and like it is considered in a different way by the browser, and it runs it as a JavaScript module to prevent doing that, and so that your script works a bit differently and reduces your processing time by milliseconds. You can actually use type equals to module in your script tag. It will help you in reducing the processing time. Next, as I told you about dynamic import, so what it does, it reduces the sizes of your bundles, right? Which will take less time. And yes, code splitting, if you guys might know, it helps you in code splitting. And the last one, module preloading. So remember, I told you about the type equals to module. When you're using type equals to module for loading your ES modules, you can also use this attribute called module preload. That is one another solution for solving the processing time issue. Yep. Now again, in this term, in case of your processing time, comes the event callbacks. Optimizing the time that it takes for your callbacks to give you the response that you want. How to reduce that? I talked about main threads, remember? Again, that is the whole crux of it, how you will be able to reduce the time taken by your event callbacks. So the first thing, just to cut it short, you can break up tasks. That is the first thing. What is the main thread? I already told you that you should remove things that are congesting your main thread. Defer code execution. Now, when I talked about set timeout, that is what is going to help you. If you want to defer some part of the code execution, which you don't require right now, you might require it after some time, you can actually use set timeout to defer the non-critical task that you are having right now. Okay. So that is one thing. And using casing away, which would again do the same thing. Like in case you would want something to some portions of the code which you don't want right now, you want to schedule it after some point of time. In that case, again, you can use async await. One more thing, checking for user input. So is input pending is one of the functions for a web API that we'll be using. It's an input device API, which tells you, let's say, remember the interaction overlapping that I was talking about. A person is clicking on the button again and again, right? So in those cases, when there are a lot of events there, what this input device API, what it does, it queues all the events in an event queue, right? And what this API is going to do, it is going to check if the user is trying to interact with the API, it returns true. If not, it returns a false. So basically, if you have a true, you can run your or move your items, those items in your main thread for execution. And the last thing is a scheduler API, something that you would want to work after a certain point of time. In those cases, you again have a web API that's a scheduler API. That's one thing you can use. So yeah, till this point, we have wrapped up how to optimize the input delay and how to optimize the processing time. Now, the third one comes optimizing the uh, process delay, as in finally, when things are going to come to you, the presentation delay that you are seeing, how to reduce that. So generally, when when your complete website is rendered on a screen, you know the process, right? What happens first? The DOM is being formed, you have the CSOM being formed, then you have the render tree, right? The CRP, basically the critical rendering path, and how does it work? The fourth step, the layouting happens, as in, okay, you have created the components, as you have the render tree with you, how you should lay out it, what should be the position, what is the height, width, and everything that you have. And then it is converted into pixels so that you can actually see it on your website. So that we'll have to consider when we are talking about the presentation delay, because ultimately what is presentation delay? It's just the time it's taking, the output that you're getting from the callback it's the time that it's taking to load on your screen, right? So these are some factors that you can actually use to reduce the presentation delay. Talking about layout crashing, it is something similar to layout shifting. So we'll talk about it. Avoid forced synchronous layouts. So let's say initially you gave certain width and height, but on rendering you wanted that no, this shouldn't be the place where the component should be. I wanted at some other place. So in these cases, there are high chances that a layout shift could happen, which would again increase the time of the calculation. Just consider that initially an item was supposed to be at this place, but on runtime you are saying, no, it shouldn't be here. I have changed or something you have done because of which the height or width might have changed, right? Now consider the browser has to again do the layouting. It has to recalculate and then repaint, which is again a very costly operation first of all, and obviously it is going to take time. So why avoid those forced synchronous layouts? Dome size, your dom depth are one of the reasons that can actually increase the presentation delay. So just keep in mind when you are creating your dom elements and the HTML that you are writing, whatever is needed, just keep those elements only in your dom and measure the dom size, the depth of the dom. That's it, I guess, which can help you in your present in minimizing your presentation delays. Also, so you might have seen images and all which you might not require in your first render, right? So in first place, why to render it? So you can lazy load elements which you don't require. The elements that as of now for your first page load, maybe you don't require them, so you can lazy load them. And next you have a content visibility property which does the similar thing, lazy loads your elements. So that is one thing that you can do. Some useful resources if you guys are interested in knowing about web performance and how it works, what are the different web performance. One of the uh, most I would say the best resources for understanding web performance would be web.dev. Web.dev is written by Google employees only, the developers at Google. So these are the two resources which you can use to understand that how INP is working, how web vitals are working. So apart from core web vitals, also you have a lot of web vitals, right? So you can go and check those useful these resources on web.dev. And yeah, that's a wrap. Thanks a lot for having me. Apart from this, guys, like apart from working also, I am quite active these days on GitHub in creating a lot of content related to interviews, since it's been just 6-7 months prior to which I was actually applying for interviews and all. So all the learnings that I had, I've kept them in a repo. I'm creating repos that can actually help front-end engineers to maybe excel or help in front-end interviews. And yeah, thanks a lot for having me. If you guys want to connect with me, that's the QR. Thanks a lot. Thanks a lot, guys.